Okay, so let's talk about triangle inequality. So, triangle inequality theorem. The sum of the lengths of any two sides of a triangle. Okay, let's stop right there. So if I have lengths of any two sides of a triangle, I have this side and I have this side. So what this theorem says is that if I add these two sides of the triangle, it will always, their sum will always be greater than the other side, which makes complete sense with what we were looking at here, right? I'm just saying it in the reverse. So if the shortest distance to somewhere is, the shortest distance to someplace is a straight line, right, then isn't the other route always going to be longer? So isn't this side of the triangle plus this side of the triangle always going to be longer than the other side of the triangle? Yeah. Yes. Okay, so that's what they're stating in this theorem. So this says, example, AB plus BC. Here's AB, here's BC, is going to be greater than AC. BC plus AC will be greater than, here's BC, here's AC, AB. And AC plus AB is going to be greater than CB. Okay, so using that theorem, let's look at the first example. Determine whether the given measures can be the lengths of the sides of a triangle. Okay, so if I have a triangle, draw ourselves a little triangle here. We don't want one with arrows, so let me fix that. I'm going to make it blue. It doesn't really matter what my triangle looks like because I'm just comparing the sides of it. So I've got one side that's worth 2, one that's worth 4, and one that's worth 5. So let's try this out. 2 plus 4 must be greater than 5. Is 6 greater than 5? Yes. So check, that works. 4 plus 5 must be greater than 2. That works. 9 is greater than 2. And what's the last side I need to check? 2 plus 5. 2 plus 5 must be greater than 4. And 7 is greater than 4. So is this a triangle? Yes. If they didn't add up, it wouldn't be. Okay, originally I was going to have you put this in your clickers, but let's just do this quickly. Example 2, which of the following could not be the value of n? Look at that quickly. Raise your hand if you got it. Raise your hand. Okay, good. Rima. 18? What do you guys think? Let's examine. So what do we talk about? It has to be greater. So 8 plus 14 has to be greater than this number. What about this number and this number must be greater than this side? Right? Okay, good. It's 6. Not, yes, not to be the value. All the rest of these will work. Because if I add 8 plus 6, that has to be greater than 14. 14 is not greater than 14. They're the same. Question? A little bit tricky. Okay, the next thing we need to do, and this is the last thing we're going to do today, is determine the range of values that y, z can be. You think it could be 1 to 6? I don't think so. Okay, this is the way you do this. So everybody get ready. Alright, first let's look at yx. Yx plus, here's yx plus xz has to be larger than zy, and xz plus zy has to be larger than yx, and finally zy plus, here's z, here's y, has to be, plus yx has to be larger than xz. So let's fill this in. It's easier to write the segments out like this first, believe me, because once you start using variables, you're going to get mixed up. Okay? So yx is how much? 8 plus xz, 14, has to be greater than n. Xz is 14 plus zy, n has to be greater than 8, and zy is n plus yx, 8 has to be greater than 14. So how do I solve this one? So 22 has to be bigger than n, or n has to be less than 22. If I were to subtract 14 from both sides, we may need that higher, then n would have to be larger than -6, which doesn't make much sense on a triangle, but we have to include that one, okay? And then if I subtract 8 from both sides, I would get n has to be larger than 6. We'll make sense of it in just one second. So we're going to talk about the range. Now, I don't need a bunch of numbers on a number line because I'm really only talking about 3 numbers. What's the lowest number? You guys remember how to graph on a number line, an inequality? So how do I put n is less than 22? Open circle or closed circle? Open. I'm going to show you a different way to plot these. Another teacher showed me this, and I really, really like it. Instead of making a bunch of lines on here for intersections, we're going to just do this. N has to be less than 22. N has to be greater than -6. I'm sorry? You'll see. And n has to be greater than 6. So the old way to do it, Megan, was to draw 3 number lines and then make little dashes where they intersect each other, where all 3 would intersect. If you look back, you did. If you had number lines, we would see if something was greater than and then something was less than, and you'd have to see where they intersect with each other. Yeah, you do arrows. But then if I have 3 different arrows going on, how am I going to see which ones are going which way? Right? So this, before you'd be using an arrow going this way and an arrow going this way, and we'd see their intersection, but now I've got an arrow going this way, one going this way, and another one going this way. So I want to be able to see all of them separately. See that? So where do they intersect? Where do all 3 cases intersect? N has to be smaller than what? 22, but larger than 6. See how that works? See that? Get it now? Okay, question? Good. All right, that's it for today.